Next important question, we are having a series. Now let Pn, we are having, let Pn be the Pn, we have to write this let Pn be the statement given by Pn is such that it is 1 upon 1 times 2 times 3 plus 1 upon 2 times 3 times 4 plus 1 upon n plus 1 n plus 2 is equal to n with n plus 3 upon 4 times n plus 1 n plus 2. Now, let this be equation number 1. Now, step number 1. Step 1, basic step. For n is equal to 1. Now, P1 is equal to 1 upon, now again I am telling you I am putting n is equal to 1 on this term, 1 upon 1 times 1 plus 1 times 1 plus 2 is equal to 1 with 1 plus 3 upon 4 1 plus 1 1 plus 2. Now, this is equal to 1 upon 6 is equal to 1 upon 6. Is it clear? So, 1 times 2 times 3, first term is also 6, 1 upon 6, and right hand side also becomes 1 upon 6. Thus, P1 is true. Now, step 2, the induction step. That is for n is equal to k. Now, assume that Pk is true, then no. 1 upon 1 times 2 times 3 plus 1 upon 2 times 3 times 4 plus 1 upon k times k plus 1 times k plus 2 is equal to k plus 3 upon 4 times k plus 1 k plus 2. Now, let this be equation number 2. Now, step 3. For n is equal to k plus 1. Now, to obtain Pk plus 1, add k plus 1th term, that is, now k plus 1th term means what I am going to write it? Now 1 upon, now in place of this k or in place of this n, I am going to write k plus 1. Okay. So, we are having k plus 1 first thing, then k plus 1 plus 1, and then k plus 1 plus 2. Is it clear? K plus 1, k plus 1 plus 1, k plus 1 plus 2. Okay. Now, this is equal to 1 upon k plus 1, k plus 2, k plus 3 to both sides of equation 2. Is it clear? So, what we are getting? We are getting 1 upon 1 times 2 times 3 plus 1 upon 2 times 3 times 4 plus 1 upon k, k plus 1, k plus 2 plus 1 upon k plus 1, k plus 2, k plus 3 is equal to k plus 1, is equal to k with k plus 3 upon 4 k plus 1, k plus 2 plus 1 upon k plus 1, k plus 2, k plus 3. Is it clear? Now, this becomes what? Now, this becomes 1 upon 1 times 2 times 3 plus 1 upon 2 times 3 times 4 plus 1 upon k plus 1, k plus 2, k plus 3 is equal to k, k plus 3 upon 4 times k plus 1, k plus 2 plus 1 upon k plus 1, k plus 2, k plus 3. Is it clear? Now, this is equal to, now this is equal to means this is equal to, now this becomes 1 upon k plus 1 and k plus 2 as it is, and now here we are left with k times k plus 3 upon 4 plus 1 upon k plus 3. Okay. Now, this becomes 1 upon k plus 1, k plus 2 with k times k plus 3 whole square plus 4 upon 4 with k plus 3 after taking the LCM. Now, this becomes 1 upon k plus 1, k plus 2, k plus 3, 4, and here it becomes now this becomes k cube plus 6k square plus 9k plus 4. Okay. Now, this becomes k plus 1 whole square after using the hit and trial method, and 4 with k plus 1, k plus 2, k plus 3. Now, this is equal to now k plus 1 whole square and k plus 1, this cancels. So, we are having k plus 1 with k plus 4 upon 4 times k plus 2 with k plus 3. Now, this is equal to right hand side of equation 1 for n is equal to k plus 1. Let us check it. Right hand side of equation 1, in place of n we are having k plus 1. In place of this n, k plus 1 plus 3, k plus 4, 4 as it is, n k plus 1, k plus 1 plus 1, k plus 2, k plus 1 plus 2, k plus 3. So, right hand side of equation 1 for n is equal to k plus 1 is true. Or don't write this here, it will let it be this one. No. Therefore, pk plus 1 is true. Now, since pk is true, implies pk plus 1 is true. Therefore, by the principle of mathematical induction, therefore, by the principle of mathematical induction, Pn is true for all n where n belongs to natural number. Proved.